The length of a rectangle is 3 meters greater than twice its width. The area of the rectangle is less than 55 meters squared. What are possible dimensions of the rectangle to the nearest tenth of a meter? So we have a rectangle. We'll draw out a picture here. This is often in questions like this, you just start analyzing things as you go along, draw pictures, see if we can understand, and then create an equation. So the length of the rectangle is compared to its width. So I'm going to choose x for the width, and the length is 3 meters greater than twice the width. So that would mean twice the width plus 3 meters gives me 2x plus 3 for the length. So the first part is reading the questions and coming up with a diagram and having things labeled. Now we know that the area of the rectangle is less than 55, so I would find area by doing length times width. That would be my area. Maybe I'll just temporarily say this is my area. And what do I know about that area? That area is less than 55. And now we have to come up with possibilities of solving for this. It's an inequality, so what we do is we make one side equal to 0, so I'm going to multiply this out, 2x squared plus 3x. I am going to subtract the 55 and make it less than 0. And now we have to solve this. Now personally, I would probably start by, because I always like factoring. We're going to find out that factoring doesn't work, but that's like, this is how I would have been like, oh, I want to try to factor this. So I'll do this, I'll write this down, but, temporarily make it equal to 0. So I think I'm going to make it equal to 0, and I'm going to factor it and be like, well, it'd have to be 2x and x. And then I run into problems here. I'm like, well, 55 is either 1 and 55 or 5 and 11. So I'm like, well, if I try 11 here and 5 here, my outside's 22, my inside's 5, that doesn't work. So I try 5 here and 11 here, because I already know that 1 and 55 won't work, and that makes my outside 10, inside 11. That doesn't work. So things are not working with factoring, which means I have to go to a quadratic formula. So now how do you solve with the quadratic formula? X is equal to negative b plus or minus b squared, which would be 9 minus 4, a is 2, and c is negative 55, over 2 times a. And we go to our calculator to type this in. And I would type it in exactly as I see it, negative 3 plus the square root of, and this will be 9. And I don't even want to do that mental math, so I'm going to do 9 minus 4 times a times c. I guess I can do the mental math on the bottom. So this would be one answer, 4.547. And if I change that plus or minus to a minus, so again, the nice thing on your graphing calculator is you can highlight something to retype it, and now all I want to do is change this plus sign to a subtract sign. And I get my other answer is negative 6.047. Now that's solving for x. And it's an inequality, so we put these numbers on our number line. And it's less than 55, so we'd have open circles here. And we're going to have to find out where things are true and false. I often like to use 0 as my test point. And if I plug in 0 for x, is negative 55 less than 0? True. And these sections would be false. Now we've solved this algebraically. The answer to this question is not that x has to be between negative 6.047 and 4.547. That's the section that says true. Why is that not the answer? Well, we have to think of the context of the question here. And what did the question actually ask us to solve? The question asked us to solve for dimensions, right? What are possible dimensions of the rectangle? Our x was our width. Why can't I just go to my true section and say the width has to be between negative 6.047 and 4.547?
Can't have a negative.
Can't have a negative. So and if we do 2 times 4.547 plus 3, $12.095. Did it ask us to, I went to 3 decimal places because that's, well, it says to the nearest 10. So then I would have to go back to here, take my eraser off. Wow. Gotta take my little eraser. Here we go. And this one will be 12.1. And it is a word problem. What were our units? Meters. So I have to make sure that I check my rounding and check that I include my units in the end. Question?
Why is the middle true for this one?
Here is our equation.
Yeah.
I did a test point of x equal to 0. 0 plus 0 minus 55. Is that less than 0?
Yes.
True. So since one test point is true, that entire middle section will be true. If I drew this, if I solved this graphically, okay? When you find your solutions to the graph, you are finding your x-intercepts. The parabola that I was looking at was a 2x squared, which opens up. I'm looking for where it is less than 0. This will be the place where it's true.
Yeah, because I was thinking about, like, why is it all true? Because x is, like, infinite. But, yeah, I guess that makes this sort of sense.
Sort of makes sense. Okay, well, I'm kind of doing my job. I'm happy, sort of, today. I will probably go to bed just crying out of one.
Sort of happy.
Anything else that I can make it, like, clear it up a little bit more? Like, x can be anything you're thinking, yes, but then you won't have, like, if this is 100, this will be 203. That won't create an area less than 55. So that less than 55 restricted us on what our x values could be.
Is there ever going to be a point where we're going to have to, like, flip that Like there's that sign around and stuff.
Like if you divided by a negative? I would say no, because you're, for the most part, you're moving things over by adding and subtracting. And we only flip the sign if we multiply or divide by a negative. So it usually doesn't come up in this type of question that your inequality has to change signs.
How does it get harder than this?
Ooh. So you went from a kind of understanding to you want it to get harder?
Well, I don't want it to get harder, but
This unit isn't too bad, it's just about inequalities. You can circle questions 8 and 13.